I made a video about the Internet Protocol quite a while ago, and in that video I briefly mentioned how the Internet Protocol is often used in combination with something called TCP, and that happens to be what we're going to talk about today. Now actually, TCP is not the only protocol that we can use. We can also use something called UDP, which we'll also talk about in this video. But then the question remains, what exactly are TCP and UDP? Well, let's say we have some sort of network with lots of computers and devices in it, and these devices are able to communicate. Now, as we saw in this previous video I made about the Internet Protocol, the Internet Protocol is what allows these computers to send information to each other. It's what allows traffic to get routed from one place to another, and this is called, in formal terms, the network layer. Right. Basically, there is this model, it's called the OSI model, and it divides networking into layers. And this job, this task of routing the traffic to the right place, is called the network layer in that model. But then, once we are able to get traffic from one place to another, the next thing that we need to take care of is how the data transmission happens between these parties, right? And this is what TCP and UDP do. TCP and UDP are protocols that control how the computers that are sending and receiving the information behave, how the transmission of the data happens. And formally, in the OSI model, this is referred to as the transport layer, because it's about how we transport the information between the parties. So now let's actually see how TCP and UDP, how they're different, right? How do they actually differ from each other? Say we have two computers in a network, computer A and computer B. And computer A has some sort of file on it. Maybe it's like a text file. Keep things simple, right? And it's going to send that file to computer B using TCP. In other words, computer B is going to download the file from computer A. That means the same. Computer A is going to take some of the information of the text file, it's going to put that into a so-called packet of data, and it's going to send that packet to computer B. Now the Internet Protocol will take care of, getting that packet to computer B. We've already discussed that issue in that previous video, but the packet arrives at computer B, it gets received, and computer B will then send a so-called acknowledgement message back to computer A, which is also a packet. And this packet contains information about the packet that was received. So computer B sends a packet back to computer A saying, I just received packet number 1. Computer A will then proceed to send the next 2 packets, and computer B, if it receives them, will then reply again saying, I just got packet 2 and 3. And so computer A will then proceed to send an even larger amount of packets, and computer B will respond again. And it'll keep scaling up the amount of packets it sends in a row, computer A, until something goes wrong, right? At some point a packet might get lost somewhere, something happens, and then computer B will send an acknowledgement back to computer A. But computer A will then know something went wrong, right? Because the acknowledgement says, oh, I just got packet 12, 13 and 14, while computer A might have also sent packet 15, but apparently computer B didn't get it because it wasn't in the acknowledgement, so that means computer A is going to resend that packet. So it constantly knows if the packets reach the other side, and if something goes wrong, it'll resend the packets that have been lost, and it'll scale back down the amount of packets that it sends in a row. So it's constantly probing the connection by sending more packets in a row and then scaling back when something goes wrong, and it always resends packets that have been lost. So with this system, it always ensures 100% integrity of the data. So after the transmission is done, computer B will have an exact copy of the original text file that was on computer A. Nothing gets lost in transmission. It doesn't happen, right? Because if something gets lost, it gets resent. Maximum integrity is always ensured. Now this is all great, and it works really well. It's used for almost anything, right? Most things on the internet use TCP. right? Especially things that you and I use on the internet, almost always use TCP. But sometimes it doesn't work that well, and it doesn't work that well when we're dealing with real-time data. So for example, if I'm doing a Skype call, say it's just with the microphone for now, right, just an audio Skype call, that means I'm generating real-time data, live information, or live data. I'm talking into the mic, it's going into my computer, and it needs to be sent over to the person I'm talking to in real time, live. Using TCP in such a situation would cause problems, because TCP is going to do this windowing, this probing, scaling how many packets it sends in a row, waiting for replies from the other sides. And to make things worse, if packets get lost, which actually happens quite frequently, it's going to pause the connection, it's going to pause the transmission and resend those packets. Except this is a real-time live situation. There is no time to wait and resend information, because if my computer is going to wait because a packet got lost, it's going to pause the transmission and resend what got lost. Well, in the meantime, I just kept talking, so the computer is now behind, so we're creating a delay. So for real-time communications, TCP can be a real pain to use, and this is why we then use UDP. So UDP stands for User Datagram Protocol, and it works in a fundamentally different way. With UDP, if we have computer A and computer B again, instead of computer A sending a packet and waiting for a reply and all this nonsense, computer A is just going to send out the packets. It's just going to fire those packets towards computer B, and it hopes they arrive. Actually, it doesn't hope anything because it's a machine, so it just sends the packets. And the packets, well, if they arrive at computer B, nice. If they don't, who cares, right? Computer A never knows if the packets reach the other side. It just sends them out, and it keeps doing that at a constant rate. There is no windowing going on, and if packets get lost, well, they're just lost, right? The transmission continues. Now, what this does is a couple of things, right? First of all, it ruins the data integrity. If something gets lost, it's gone. Right? We're not going to resend it. Maybe it's stored somewhere on computer A in like a backup memory, but it's not going to reach computer B, because we never know the packet got lost in the first place. The other thing it does is it allows for tremendous speed. And by speed, I mean tremendous latency. Right? The latency is very small. This allows for absolute real-time communication. If you can just stream data to the other side without having to wait for acknowledgements and having to resend packets and things like this. So UDP is used in situations where data integrity is not very critical. So, for example, a Skype call, if I'm talking to someone and there is some noise on the line, or the audio cuts out for like a millisecond because there are some packets that are lost, that's not a huge deal. That doesn't really matter in a phone call, unless you can't understand the other person anymore. But most of the time it's not that bad, right? The packet loss isn't big enough to cause severe issues. There might be some noise on the line, but it's usually not a big deal if the data integrity is not 100%. Latency is, however, very important, because you don't want delays in a phone call. That's really annoying. So in this case, UDP is clearly the better choice, because we care about maximum speed, and sacrificing some data integrity is not really a problem here. In other situations, and spoiler alert, that's actually most other situations, we do care more about data integrity, especially since connections these days are so fast that we can get away with using TCP in situations where it's almost real time. So for example, if you're watching a YouTube live stream, even though it's live, the delay on YouTube's side is still so big that they can get away with using TCP. So effectively, they're just storing parts of the stream that they're getting in from the person who's doing the stream, and you're just downloading chunks of the video and playing them back. Effectively, you're doing nothing different than watching a normal YouTube video, which is also using TCP. Like, you're just downloading parts of a video and playing them back. It's not really live streaming. And the same thing goes for music streaming services and Twitch and all of this kind of thing. So there you go. Now you know what TCP and UDP are and what the difference is between these two systems. I hope you've enjoyed this video, and of course, thank you for watching.